Okay, here we go. Over here to the right, we have the graph of the function f of x equals 14 minus x squared over 14. And we want to revolve this region right here about the y-axis. And in order to do that, we need to find this point of intersection first, as well as this one, depending on which method we're going to use. Of course, this is the horizontal line y equals 7. So to find that point of intersection, we need to solve this equation. In other words, when does this red graph intersect the line y equals 7? I'm not going to go through that, but in exact form, it's 7 radical 2. Okay, and so you can use either the shell method or the disk method to find that volume of revolution. Most straightforward would be to use the shell method. So I'll go to board 2. The shell method, we're revolving these individual shells around the axis of revolution. And the formula is 2 pi times the integral from a to b of the height of the shell times the average radius. The average radius being the distance from the axis of revolution to the center of the shell, okay, which in this case will be x. So what is the height of the shell? Height of the shell is, there's the function, that's the y value. For each x on this interval, the height of that shell is f of x. Well, we're down here for x. So f of x would actually be this height. But if we subtract 7, which is what this is right here, we've got the height of the shell. And we multiply that by the average radius, integrating from 0 to 7 radical 2, which is what this point is right here, from 0 to 7 radical 2. Of course, we would simplify this before we found an antiderivatives. 14 minus 7 is 7 minus x squared over 14. And we'd multiply both terms by x, find the antiderivative, evaluate from 0 to 7 radical 2. Multiply that by 2 pi. And in the end, you'll get 343 over pi. I'll leave that to you. Now, if you did want to use the disk method, we would picture this as a radius of a typical disk. And the formula is pi times the definite integral from 0, or from a to b of the radius squared. We're not using the washer method because there's no hole in the middle. Question is, what is that distance right there in terms of y? We have to solve that original function, 14 minus x squared over 14. We'd have to equals y. We'd have to solve that for x. And then for each y on the interval from 0 to 14, this distance would be depending on the value of y that we're looking at. So that's what this is right here. Actually, y would be the square root of that, but then we would square that, the radius squared. And so that's why I just have 14 times the quantity 14 minus y, so I'll erase that. There's your there's your setup of the definite integral. Distribute the 14, take the antiderivative, evaluate from 7 to 14. You still get the same thing, 343 over pi. So remember, when you use the disk or washer method, your typical disks or washers are perpendicular to the axis of revolution. If you use the shell method, your typical shell is parallel to the axis of revolution. And you can always find these distances. If it's a vertical distance, it's the y coordinate at the top, take away the y coordinate at the bottom. So here our y coordinate at the top was 14 minus x squared over 14. Our y coordinate at the bottom of the shell, or the vertical distance we're trying to find, was 7. And again, that's where this came from. Okay, hope that helped. If you have any questions, post a comment.